I'm going to list all 4 conic sections, and notice I give you the first letter of each conic. So the first conic section that begins with the letter P would be a parabola. The next conic section that begins with the C would be a circle. Then an ellipse. And the H is a hyperbola. So those are the 4 conic sections. Some people state that there are only 3, that these 2 are actually the same shape, it's just a circle is a special version of an ellipse. Now I want to look at the slice. So if I slice a cone, and that will give me a conic section, where this line, the slicing line, is parallel to the base, the shape after that slice is going to give me a circle. Now if I do my slice parallel to the edge of the cone, that slice is going to give me a shape called a parabola. Parallel gives you a parabola. And then if I slice it not parallel or to the edge or the base, just a little strange angle there, it's not going to be a circle, it's going to be the ellipse. There's one more slice, and the last slice would be if I were to slice it perpendicular to the base. If I were to come in straight up and down and slice it perpendicular to the base, that would be a hyperbola, if I were to do that slice. A little bit different of an eccentricity than a parabola. What I want to do here is write this center radius form into general form. So I'm going to FOIL this out. That would give me x squared plus 4x plus 4. You double that to give me the 4x, and then you square that to give me the 4. I'm going to FOIL this out. That would give me y squared minus 10y. I double that. Minus 10y. Some people put an x there. And then I square that. Negative 5 times negative 5 is positive 25. And in the general form, you want to bring this 4 over to the other side. So I'm going to do my arithmetic bar. And then I'm just going to combine my terms. So x squared and y squared do not combine. So that's going to give me x squared plus y squared. They don't combine. Then I'm going to do the middle terms. That's plus 4x minus 10y. They don't combine either. Now the digits do combine. The digits do combine. 4 plus 25, well that's 29. And then I want to subtract 4 from both sides. That would give me plus 25 equals 0. And that's the general form of that circle. It would be x squared plus y squared plus 4x minus 10y plus 25. And that's equal to 0. Same thing for this. I'm going to belt it out. That's going to give me x squared plus, minus 8x plus 16. Going to FOIL that out. That's going to give me y squared plus 6y plus 9. You double that to get the 6y. You square that 3 to get the 9. Equal to 1. I'm going to do my arithmetic bar. And now I'm going to combine my terms. So x squared plus y squared, they don't combine. It's x squared plus y squared. It's falling out in general form. Minus 8x plus 6y. Now I have to do the arithmetic. That would be 16 plus 9, I believe is 25. And then I subtract 1 from both sides. Plus 24 is equal to 0. So my final answer is x squared plus y squared minus 8x plus 6y plus 24 is equal to 0. This one I don't have to FOIL out. There's only an x squared term. So I'm going to bring that FOIL out version of this right alongside of it. So x squared comes down, and then I'm going to FOIL this out. That's going to give me y squared minus 14y plus 49 is equal to 9. And now I'm going to bring everything over, bring the 9 over, and rewrite this. This is actually an addition. So that's going to give me x squared plus y squared minus 14y. And here comes the tricky part. I want to minus 9 from both sides, and that would give me 40. Plus 40, and this equals 0 over here when I cancel those out. Equals 0. I want to write the equation when I'm given the shape. So this is a circle. It centers at 0, 0, so that's just going to be x squared plus y squared. Now you have to find out what the radius is. The radius of this circle is 2. So 2 squared is 4. Number 7, on the center it goes right 2, and it goes down 2. So my center is at 2, 2. I'm going to need that to write the equation. Now this is an ellipse. So I'm going to set up a template. It's going to have a division bar. The ellipse always has a plus sign in the middle. And then another division bar. And then it's always going to be equal to 1. And now the distance along the horizontal that's parallel to the x-axis is 2 units. So 2 squared is 4. Then the distance that's parallel to the y-axis with respect to the y-axis is 1, 2, 3. So 3 squared is going to give me 9. Now it is not going to be just x squared plus y squared on the top because I have a phase shift. So I'm going to set up my x value and my y value and determine what goes here to the right by looking at the center of this ellipse. Notice it's at 2, 2. So I'm going to put a 2 here and a 2 here. But it goes right 2, down 2, so it's 2, negative 2. And because they're both quantified, we're going to do opposite, opposite, not opposite same, because they're both in a quantifier. So the opposite of positive 2 is negative 2, and the opposite of negative 2 is positive 2. This ellipse is centered at 0, 0 for number 8. So when I set up my template, it's going to be a division bar, a plus sign, a division bar, equals 1, and then I'm just going to put x squared plus y squared on the top. And now all I have to do is figure out what goes underneath in the denominator. So along the x-axis, it's 3 units long, 1, 2, 3. So I don't put 3 there, I put 3 squared, which is going to give me 9. And then along the y-axis, it's 2 units high from the center. So I'm not going to put 2 there, I'm going to put 2 squared, which is 4. This is one of our old school Algebra 1, Algebra 2, geometry type parabolas. So all I want to do is write it in vertex form. I want to find the vertex. The vertex goes right 1, down 1, 2, 3, 4. Now remember with the vertex, it's going to be opposite same. So it's going to be the opposite of 1, which is negative 1. Square that. It's only one of them squared because it's a parabola. And then minus 4 because it's same. Opposite same. For a parabola, it's opposite same. And for these closed figures and hyperbolas, it's opposite opposite. Notice it's set equal to 9, not 1, and it doesn't have anything underneath, so that's an indicator that it's a circle. So the center's going to be positive 3, negative 2. Basically, it's opposite opposite. And then the radius, to find the radius, you square root that number out there. And that would be 3. So I go to the center, 1, 2, 3, negative 2. And then I'm going to go outward to make my radius. My radius is 3, so I go right 3, I go up 3, I'll go left 3, and I'll go down 3. And then draw the curve, and that's my circle. That's what it looks like, number 11. Let's see how we arrived at this. The center is at 0, 0. There's nothing up there with the x and the y. So there's my center. I square root 16. The square root of 16 is 4, so it's underneath the x. So I'm going to go right 4. I'm going to go left 4. The square root of 9 is 3, so that means my minor axis underneath the y is going to be up 3, down 3, and then here comes my ellipse. I know it's an ellipse because it has a plus sign in between them. Number 12, there's the drawing. Once again, it's an ellipse. Plus sign. Let's see how we arrive at these coordinates. Notice, there's nothing next to the x squared, so that's going to be 0, but it's y minus 2. So the opposite of minus 2 is positive 2, so that means I'm going to go right and left 0 units, but I'm going to go opposite, up 2 units to get the center. Now, underneath the x value is a 4. The square root of 4 is 2, so I'm going to go right 2. I'm going to go left 2. Then the square root of 1 is 1. That means I'm going to go up 1, and I'm going to go down 1. And there's my coordinates to sketch the graph of the ellipse. Notice this one's a hyperbola. The reason they go outward and it's a hyperbola, it's not separated by a plus sign, it's separated by a minus sign. That's what makes it hyperbolic. So let me go over the process of getting the asymptotes, the asymptote box, and eventually the curve. So it's centered at 0, 0 because it's x squared, y squared. It's not quantified. It's a hyperbola because it's minus. So the square root of 9 is 3, so I go right 3, it's underneath the x. I go left 3, the square root of 4 is 2, I'm going to go up 2, and I'm going to go down 2. Now some people go ahead and draw an ellipse, but that's not what we're drawing. We're not drawing an ellipse. That would be if it was a plus sign up here, but it's a minus sign. So I have to get rid of that ellipse. I'm actually drawing a hyperbola. And a hyperbola uses a thing called asymptotes. So I'm going to make an asymptote box using these coordinates as a guide. And notice, all 4 sides of this asymptote box go through those coordinates that I derived from up here in the original equation. Now I'm going to draw the asymptotes. That's an asymptote box, but I need to actually graph the asymptotes for this hyperbola. And notice all you're doing is connecting the corners and extending it through the corners and through the center of the shape. Now to draw my curve, some people don't know when to draw it up north or when to draw it on the side. The way to figure this out is to look at which value comes first. If the x value is in front of the minus sign, that means your hyperbola is going to be sketched with respect to the x-axis. The only way to get it sketched with regard to the y-axis is for the y squared to come first. Number 14, the characteristics. To find the length of the major axis, that's the long axis, all I need to do is count the length of this axis. And if you count across, it's 10 units. To find the length of the minor axis, all I need to do is count the length of this small axis. And notice it's 1, 2, 3, 4, 5, 6. Now this is the challenging part, and that's to find the foci. Now to find the foci, I'm going to use something very similar to the Pythagorean theorem. It's a squared minus b squared equals c squared. And the c squared is what generates the foci. So to find out what a is, all I need to do is count along the major axis. And notice it's 5 units long, so that means a is going to be 5 squared, or just 25. To find the b value, all I do is count along the minor axis. Notice that's 3, so 3 squared is 9. Now that's going to equal c squared. 25 minus 9 is 16. To find the value for the foci, I need the square root c squared, and I need the square root 16, and that's going to give me a value of plus minus 4. So from the center, I go left 4 and right 4, because it's going to be along the major axis for the foci. 1, 2, 3, 4. That's my leftmost focus. 1, 2, 3, 4. That's my rightmost focus, so the values are going to be negative 4, 0, and 4, 0.
I want to know what the length of the major axis is. That's the longest axis. So I'm going to come across this long side and count that. That's 5 to the center. And then another 5 all the way across to complete that major axis, and that is 10. And then I want to find the length of the minor axis. And the minor axis is going to be the short side. So that's 4 to there and another 4. So the length of the minor axis is 8. And now I want to find this thing called the focus. Or both of them, foci or foci. It's pronounced either way. And that has a formula, a squared minus b squared is equal to c squared. And a is this length along the major axis, which is 5, but 5 squared is going to give me 25. So I might as well just write 25 there. Minus b squared, that's 1, 2, 3, 4. So 4 squared would give me 16, and that's going to give me c squared. Well, 25 minus 16 gives me 9. Now I want to solve for just c to get the focus. So square root of c is the square root of 9, and that's going to give me plus or minus 3. So what this translates to on the actual ellipse is that I will go right 3 and left 3 along the major axis. I go right 1, 2, 3, and that's a focus point, and I go left 1, 2, 3, and that's my other focus point. So the foci, or foci, is located at negative 4, 0, negative 3, 0, and 3, 0.